Good afternoon, everyone. My name is Heng, representing Teambuild, with two challenge statements here. Yeah, so basically, the background is such that I think earlier Mr. Bonis did mention about PVBC. So basically, Teambuild also does PVBC production. So after which the layout is being planned, right? The cages, before you do any concrete PVBC volumetric construction, you basically need the rebar and the meshes to be assembled. So right now, what you see here is basically there's a few steps from step 1 to step 3. So basically, the step 1, before you do any assembly of the reinforcement, you basically need to interpret the drawing. And the drawing are quite complicated and it can be as many as up to 10 over pages. So basically, the worker supervisor need to interpret the drawing. So the parts, as you can see in the photos, is about, you get more than 100 of items, which they really need to identify the individual parts and the assemble. So with this challenge statements, basically we are looking at how we can assemble the cage with a shorter time. Next slide, please. Yeah, so currently the practice of is basically what you see on the drawing. Basically, it's a A3 drawing printed out. Sometimes you can print out to A2. So the worker supervisor really need to interpret and identify what are the parts to use before they can really assemble. So you can imagine like it's a Lego. If your kids play Lego, they have an instruction where they have number of parts and the individual assembly instruction. In our case, it's just a total assembly drawing without any instruction on which part to assemble first. So this leaves a lot of prone to error or a lot of time consuming where the operators, worker need to try and error which is the best and more efficient method to really assemble the whole cage together. So at the start of every new project, a lot of time is wasted as in exploring which is the faster method or which method is faster to assemble the cage. So basically, we are looking, the impact is basically if you can interpret the drawing faster, you can actually improve your productivity. Just a guideline, currently the engineer supervisor will need to interpret about up close to 3 hours for any new drawings. So as they get more proficient, they can basically reduce to 1.5 hours. So if more workers is able to interpret the drawing more productively, then the production of the PVC will eventually become more productive. Right now, it's basically depending on the supervisors and engineers to interpret the drawing. But if more people can really understand the drawing, then it'll be more productive for the whole production line. Next slide, please. So basically, we are looking at the solution as in we can analyze the drawing or the 3D models. Right now, we already have the 3D models drawn in Tekla, precast function. Basically, we also look at the 3D models, but it's in the assembly stage. So if we can have a software base where the worker can use a PDA, they can really zoom into an interactive way of assemble like part 1, part 2, how you basically assemble piece by piece together. It will be very helpful for the team to actually speed out the production works. Right now, it's basically this like jigsaw puzzle. They really have to see how we can assemble the whole cage. So the solution that we are looking at is basically is a software based PDA where they can really zoom into. They click on certain part, they can zoom in, and how we can interactively show how we can assemble parts together. So this is the solution that we are looking at. Next slide, please. Next slide. Next slide, please. Yeah, so basically we hope to reduce the time taken to interpret the drawing to maybe about an hour. So it also improve the accuracy of the interpretation. So if the software itself can really predetermine the steps, then it will be a standardized method of assembly rather than for every different team of people doing the cage assembly, you usually have different productivity. But if the software can really fix the method as in like Lego or you do modeling, you can have a fixed procedure, then you can really reduce the time taken to actually interpret the drawing and eventually improve the overall productivity. Yeah, that's all from my side. Any questions?
So, Mr. Lin, just to ask a question regarding what you have just shared, that this rebar cage assembly is very much like Lego and putting puzzle pieces
Yep.
together. What is the principles and strategies in assembling this rebar cage? Like, is it the inner parts first, then move to the out?
Usually we break the 3D cage into two main components. One is the slab. So usually we will assemble the slab portion first, followed by the wall, because the slab forms the base of the entire cage. So if you can get the accuracy of the slab right, so basically the wall surrounding the slab basically just form around it. So it's usually quite standard. The challenge is basically to really identify where the parts and this so-called, let's say, part number 54, where should this part go to? Right now, they really have to search through the drawing, identify the parts, and then find the correct location at the drawing. So if it's a 3D model, basically, you can just zoom into, okay, I want to find part 54, where should be this part? I just need to click. You can really zoom into which portion of the 3D model. Then it can really help the team to speed up the process.
Mhm.
Yeah.
Yep. So this question is from Angeli. Are you able to label the rebar part?
So far, the parts are all come with individual text. The text from suppliers basically it varies from handwritten to printed. Of course, one of the suggestion was basically the workers can scan the text, but then unfortunately, imagine there's 100 over items per cage. So basically, you really have to lay your materials all over the ground, then you can really identify. Individual parts will come with individual text.
Mhm. Yep. So currently, the workers rely on verbal instruction.
Correct.
How how do you see the best way to educate and train your workers? Is there any linguistic consideration?
So basically, for every station, the supervisor will have a charge hand and the second in charge. So the charge hand basically is the one who is more proficient. So the instruction given from the supervisor will tell them, okay, you focus on the slab, which portion to take care. Then they will start to do the marking, follow which another worker will go and source for the parts. So the parts are all lying around the cages. So basically, they need to identify the shape from the drawing. Then they go and look for the particular bar mark or the part number. Then they can place close to the assembly area, followed by assembly the cage.